Welcome to a major turning point in the course, Object-Oriented Programming, or OOP. Until now, we've used procedural programming, focusing on writing functions or procedures that operate on data. OOP is a different and powerful paradigm that structures programs around objects, which are essentially real-world entities. 1. What is object-oriented programming? OOP is a method of designing programs using concepts like classes and objects. Instead of viewing a program as a sequence of steps, we view it as a collection of interacting objects. Think of a car. It's an object with attributes like color and speed, and actions like accelerate and brake. 2. Why is OOP important? The shift to OOP offers several key advantages for large software projects. Firstly, it offers modularity by grouping related data and functions together. Secondly, it provides reusability because we can create new objects from existing classes. Thirdly, it offers maintainability, making code easier to update and debug because changes in one object are less likely to affect others. 3. Procedural versus object-oriented. In procedural code, data and functions are separate. You pass data to a function to operate on it. In OOP, data and the functions that operate on that data are bundled together inside an object. This creates self-contained entities that accurately model real-world concepts. To summarize, OOP is not just a coding style, it's a way of thinking about program architecture. It's essential for working with frameworks and building scalable applications. These 4 principles, encapsulation, abstraction, inheritance, and polymorphism, form the foundation of OOP. Join me in Lecture 16.02, the 4 OOP principles. See you there.